In this problem, we're given a chemical reaction which does not matter. We are also given a table of reaction data. We're given the concentration of A, presumably that's in moles per liter, for different times, which are in units of seconds here. So at time 0 we have 1.05 molar, and the concentration gradually decreases. And we are monitoring apparently this reaction every 200 seconds here. Now it says don't solve the problem, just outline the steps or strategies or method that you would use to solve this problem. Now for this chemical reaction, we are not sure if this is a zero order, first order, or second order reaction. So what I would want to do first is graph concentration versus time and see if the reaction is a straight line. I would then want to graph the reciprocal of that. And then I would want to graph the natural log versus time. Now, if it came out to be a linear plot for the graph of log A over versus time, this would be a first order reaction. And the half-life would be constant at all time periods. So I'd probably just use the graph maybe to determine that. So if I graphed natural log versus time and it was a nice straight line, well, on second thought, I'm thinking that maybe I should just use the integrated rate equation to figure that out. So the next thing I would want to probably do is use the integrated rate equation. For whatever graph it turned out to be linear, and I would solve for k and then eventually plug it into the half-life formula. Okay, those are the steps I would take. This might be all Greek to you if you're really unfamiliar with these reactions, but if you're at the point where you're very comfortable with this part right here, concept number 1, if you're really comfortable with the integrated rate equation, you know that there's a k in it, and you probably are familiar with the half-life formula as well.